we just use this implementation as a way to motivate the need for software testing. We wrote this MinMax implementation and then we started to do some testing, and then right in the second test we did, we actually found a bug. And this is what this course is about, to study techniques that will help us in revealing bugs. But this course is also about making sure that the test code we produce is of high quality. After all, we want this test code to be easy to be understood by other developers. We want test code that is easy to be extended by other developers, and etc. And if I look at this implementation right now, I see that there's lots of duplicated code. I see, for example, the instantiation of the class under test. They are repeated between the tests and I don't see really why. I also see that the overall structure of the test method is quite similar between them. So they all need a array of integers as an input, and then they do the assertions in two values, the max and the min. So a lot of duplication, right? And if you think about it, let's suppose a developer wants to write more tests. The person would have to have more methods that share a similar structure. So very quickly, this test class would become very large. And there's no real reason why, right? We know how to avoid duplication. And that's what we're going to do. And let us look at the refactored version now. So the main method here is this valid list of numbers. And this method captures the structure of the tests we were writing before. So it calls find to a array of integers, and then it does the assertion in two values, the min and the max. And those values now are not hard-coded anymore, but they are parameters of the method. So the array of integers, which serve as an input, and then the two other integers, the expected min and max, which serve as the output that we are expecting. And we can do this by using the parameterized feature of JUnit. So note here the add parameterized test instead of the add test. So this is what a parameterized test is about, right? So we write a generic test code, and then the values are replaced in runtime by the parameters of this method. So with this, we kind of solved the duplication problem already, because we don't need to repeat the same code over and over again. But we need to feed this test method now with concrete values. And for this, we need to define a source. And in here, I'm defining a method source, which is I'm going to implement a method that will feed inputs to this class. I call this method generator. I could call it whatever I wanted to. And the signature of this method is simple. It receives nothing and it returns a string of arguments. Arguments is this JUnit class, and it is there that you're going to pass the values that will be replaced by the parameters. So there are 3 here, and then there are 3 here, right? And in the same order, of course. So for example, my first test is the list in a descending order. I'm passing an array of integers that follow this, so list in a descending order, 27, 26, 25, and then the expected min is 25, the expected max is 27. So this is one argument. I'm going to create another one. So numbers in random order, which I pass a list of integers 5 to 15 and 27. I know that the expected min is 2, the expected max is 27. So I have 2 different test cases here, and I just return them both. Stream of test case 1, test case 2. When I run this, you're going to see that JUnit will run this valid list of numbers, but it will run it twice, or one for each argument I'm passing there, which is what you can see here. Yeah, great. So this means that for a developer to now write more test cases for this problem, he or she would only need to create more arguments. So for example, let's test one more. So if I pass 1 and 1, which means that the max is the same as the minimum, let's pass it here. So test case number 3, I run it, and now JUnit will run the test 3 times, 1 for each of the inputs I pass. That is really, really nice, right? Because now everything is just simpler to understand, and that's what we need to aim for. There was another small change that I did, maybe you noticed, which is the instantiation of the class. I'm doing this together with the field declaration. So I declare the MinMax, which is the class under test, as a field of the class, and I instantiate it inline. Behind the scenes, JUnit instantiates the MinMax test class for each method, for each test method that we have. So this means we will always have a clean version of this MinMax class. So the instance will be always a clean instance of this MinMax class for each test. So maybe you're more familiar with this when this is done in the before each method. So this is something I actually see people doing a lot. Instead of instantiating it inline, the person does something like this. Declares the field and then instantiates it in the before each. If I run this, the overall result is the same, right? I just prefer to do this in a single line as I did before, like this, because the instantiation of this, the class under test, is very simple. It's just a nil class, so why not do this in a single line? I use the before each when the initialization of the class is a bit more complicated. We are going to discuss a lot about test code quality in the test code quality lecture, but for now I want you to have in your mind that code quality is fundamental. So once your tests are done, put some effort in making sure that this test suite is easy to be read and easy to be extended.